month we're going to talk about Jupiter, the giant of the solar system. And this is a very good time to do it because Jupiter is so well placed. It's nearly at opposition. That's to say, almost opposite the sun in the sky, and so it's due south at midnight. And it's bright, brighter than anything else in the sky, apart from the sun, the moon, and Venus. At the moment, it's in the constellation of Pisces, the fishes, near the square of Pegasus, and there's nothing, anything like so bright anywhere near it, so you can't mistake it. It's visible throughout the hours of darkness, and a small telescope will show plenty on it. Now, I said Jupiter is the giant of the solar system. That's true. Imagine that globe represents Jupiter. On the same scale, the Earth will be a plum. So remember also, Jupiter is a long way away, more than 400 million miles. I mean, that's quite a distance. Jupiter really is a strange and a fascinating world. And now I come to my two distinguished guests, Doctors John Rogers and Lee Fletcher. Welcome to the Sky at Night.
Thank you for inviting us, Patrick.
John, may I come to you first? We've seen these features on Jupiter. What exactly are they? What are they made of?
Well, everything that we see on the surface is made of clouds, Patrick. So we're looking at different colours and different thicknesses of clouds. The brighter areas have thicker white clouds, and the darker areas are partly transparent, but they also have clouds that are brown, various shades of grey and brown.
Can we say a bit more about the composition of the clouds, Lee?
The clouds that we see on Jupiter are in the region of the atmosphere where the temperature of the atmosphere is decreasing with height. So as you get to a certain altitude, a certain gas, the first one is water, will start to condense out. You go higher and higher, you get ammonium hydrogen sulfide. Then the top level one is ammonia ice. So that ammonia ice cloud, we believe, is what's causing most of the visible structure that you see on Jupiter.
What about the belts?
The belts are largely the same, but because you have air being squeezed together and pushed down into the interior of Jupiter, all of those cloud decks are a lot deeper. And so the differences between the zones and the belts is often to do with the altitudes of the different cloud decks.
But is it gas all the way through, John, or is it a solid interior?
There's believed to be a rocky interior, but that's deep down in the centre, which we can't access.
I imagine it's pretty hot inside.
It's certainly thousands of degrees down there, and at exceedingly high pressure, something like 3 million times the atmospheric pressure of Earth.
In fact, the pressure is so high deep down there in the centre that hydrogen, which is the simplest element in the universe, starts to take on an extremely exotic form. It becomes what we call metallic hydrogen. It can actually conduct electricity, and it's within that metallic hydrogen centre that we think Jupiter's intense magnetic field is being created and formed.
Any liquids, sir?
Yes, because although what we see on the surface is gas, as you go deeper down, the pressure becomes higher and higher, and so eventually it becomes a liquid, simply under the immense pressures.
What are the belts made of? Are they higher or lower than the bright surface?
What we think the belts are made of are regions where the atmosphere is actually sinking deeper into the planet. And when it sinks, it squashes the air together. You know from when you pump up a bike tyre that when you increase the pressure, the temperature goes up. It dries out the atmosphere, and it's that drying out which allows us to see the darker brown colours of Jupiter's deeper interior. Compare that to the zones, which are the much brighter regions, where we think gas is rising upwards, expanding, cooling down and dredging cloud materials and other gases from the deep interior up to where we can detect it.
What exactly is the Great Red Spot?
It's a great big storm in the planet, circulating anti-clockwise, which means that it's an anticyclone. That is, a circulation around a high-pressure area in the atmosphere, comparable to the sort of anticyclones that we see on Earth, only much, much longer-lived and much deeper.
What causes the red colour?
It's something that scientists still don't really understand, what the material is that makes the red spot red. But we do have an idea. We think that when a storm strengthens in intensity, it deepens as well, it stretches vertically. And as it stretches, it gets access to a reservoir of sulphur and phosphorus-bearing materials deep down. It pulls those up to where the sun's rays can start chemically altering these compounds, and it's that chemical alteration which somehow produces the red colour. But the exact chemical compound is a mystery that I know I'd like to try to make some ends in resolving sometime.
Well, there is a real mystery now, as far as I'm concerned. Normally, you have two major belts, one to either side of the equator, for North and South Equatorial. And the South Equatorial has suddenly done a finishing act.
Some sort of change occurs deep within the belt that shuts off all of the fine-scale turbulent structure we normally see near the Great Red Spot. Once that's shut down, this fade begins to occur. And what the telescope measurements we've taken are beginning to show is that the atmosphere cools down in that location, which is telling us that air is rising upwards, cooling, and allowing ammonia ice crystals to condense. And that ammonia ice is what's causing the white appearance of Jupiter's south equatorial belt.
How long do you reckon it'll be before Jupiter returns to what we regard as normal?
Well, this faded state can last anything from 1 year to 3 years, so it'll probably revive within the next year or so, but we can't say exactly when it will be or exactly where it will start. When it does, we expect it to be spectacular, because the revival of the South Equatorial Belt always starts with a very vigorous outbreak, like a gigantic thunderstorm at one place, and then in intense turbulence and vortexes and convective clouds spread out from that centre and reconstitute the belt as they disrupt the thickened cloud cover that has formed.
Sometimes our Earth is hit by large bodies, meteoroids, and they make craters even. Well, Jupiter is not immune, and several times recently it has been hit.
Yes, we were very surprised last year when Anthony Wesley, an astronomer in Australia, discovered a small black spot in the South Polar region. And so astronomers all over the world started observing it to see what would happen to it and to try and find out what it was.
We applied for time on a range of telescopes around the world. And these are huge telescopes capable of looking at Jupiter at lots of different wavelengths of light that are sensitive to different things like clouds, like the gaseous composition and the temperature structure. And what we've started to realise after analysing this data for 12 months is it triggered a chain of chemical reactions that tell us a lot about what that body was made up of and where it came from. In fact, it triggered a certain type of chemistry that you can only get if you don't have any water being brought in with the body. Now, straight away, that tells us that we believe this was an asteroid rather than a comet that hit Jupiter in July of 2009.
What do you think of these recent impacts on Jupiter, assuming they are impacts?
Well, they've been very exciting. One was discovered just a year ago by Anthony Wesley. He was looking at his video as it recorded webcam images of Jupiter, and he saw this flash on the surface, and he realised that it was probably a real fireball in Jupiter's atmosphere. And indeed, Chris Goh, another amateur astronomer in the Philippines, recorded the same flash on his video at exactly the same time. And we thought that this was pretty exceptional, because this was the first time that anyone had ever recorded an impact live on another planet. But now, just on the 20th of August, just a few days ago, a Japanese astronomer, Mr. Tachikawa, recorded a similar flash. And that one has been confirmed by two other Japanese observers who were also recording images at the same time. So that's two flashes within less than 3 months. So now we realise that these are actually detectable quite often.
But the last two didn't leave any visible effects.
If you look at certain different wavelengths, you are able to detect the debris field from these giant collisions. We were able to use all of the telescopes that were available to us at the time, and we saw absolutely no debris. So these two flashes that have occurred recently, they're more like shooting stars, if you like, burning up high in the atmosphere of Jupiter. I think this is a great example of how important it is to have amateur observers and professional astronomers working together, because the key advantage that amateur observers have is an immense amount of time and an immense amount of patience.
So Jupiter experts like you have a great deal to look forward to.
And a lot to keep us busy as well.
Absolutely.
Lee, John, thank you very much.
It's been a pleasure.
Pleasure.
Well, I'm glad to say the sky is now clear and Jupiter's there waiting for us. And in my garden are Paul and Pete, so let's join them.
The wonderful thing about Jupiter throughout September is that it's really easy to find. All you have to do is go out in the garden when it's clear, look to the southeast, quite low down, the bright starlight thing you can see, that's Jupiter. Now, just to remind you where Jupiter is in the sky at the moment, it actually sits underneath a faint circle of stars, which is known as the circlet in the constellation of Pisces the fish. The circlet itself sits underneath a great big square of stars, which is known as the Great Square of Pegasus. So that locates where Jupiter is amongst the constellations. Now, wonderful though it is to look at with the naked eye, if you have a pair of binoculars and you point them at Jupiter, if you can hold them steady enough, and that's not always an easy thing to do, you should be able to see 1, 2, 3, maybe even 4 tiny points of light either side of the planet. And these are the so-called Galilean moons. Now, if you want to see Jupiter a bit closer up still, you have no choice really but to go and look through a telescope. I've just been looking at Jupiter through my binoculars, Paul, and I can just about make out a couple of the tiny moons either side of it with these.
But that's about all, isn't it, with binoculars? To see anything really sort of more spectacular than that, you do need a telescope.
You do.
And this is quite a nice one, don't you think?
It's excellent, but this isn't an expensive setup, is it?
No, it's not. It's just a 3-inch refractor, a very nice telescope, sort of telescope we might all start out with.
Yeah.
I've got here quite a nice view of Jupiter through the eyepiece. You can see the sort of squashed disk and the bands crossing it. But that's about all. There's structure there, and you'll see things like the Great Red Spot, but no colour and no sort of fine detail.
Okay, so when you see these features, you can, because Jupiter rotates so quickly in about just under 10 hours,
that's right,
you can actually see them move across the disk as the planet's rotating.
That's right, and you get a feel that this is really a giant planet a long way away and very active. So
Okay.
you do get that at least with a telescope this size.
Okay, but for something a bit more substantial, we need to look through something bigger, don't we?
That's right, let's do that.
Okay.
Well, here we are, Pete, with Patrick's 15-inch reflector. Normally an eyepiece in there. What have you done with it?
Well, what I've done, Paul, is I've taken the eyepiece out and I've inserted a camera, so we can see on the monitor down here what you'd normally be able to see with your eye.
Okay.
And there's quite a bit of detail you can pick out there.
It's very impressive. The extra inches make all the difference, don't they?
They do. I mean, with a larger telescope, you've got better resolution on the planet.
There's colour coming through.
That's right. The extra light allows you to see that extra colour. And you can see that the belts there, which are standing out quite well, are actually quite brownish in colour.
They are. There's some structure in the belts, and you can see some of the various storms mottling in the polar regions where the storms would be. Quite impressive. So what would you be doing on a typical night? You got Jupiter in the sky, what would you be doing?
Well, I like to take photographs of it, images of it, with a fairly large telescope, try and get high resolution definition on the features. So where you're seeing sort of a hint of undulation in the belts there, you can actually go and you can see the tiny little spots and features which are in there.
All that dynamic detail you get.
That's right. If you take lots of stills, you can actually animate them together, and then you can see how the planet rotates, and you can see how the features move relative to each other.
I see.
What would you do then?
Well, after I've made the drawing, what I'd like to do is make transit timing. Transit timing is basically a way of measuring the wind speeds on Jupiter.
Yeah.
And the principle's very simple. It's rather like dropping a twig in a stream. You know how fast the twig is moving, then you know how fast the water's moving underneath.
Yeah, that makes sense.
And so what you do is you get your spot or storm, and when it's on the central meridian, note down the time.
That's the imaginary line that runs right down the centre of the disk.
That's
okay.
right. And you convert that time into longitude, and if you do that over successive nights, you'll notice a drift in longitude.
Fantastic.
And that's entirely due to the wind speeds in that stream.
That sounds pretty simple to do.
It is. It requires no speciality or talent on my part at all, Peter.
But you need to have very accurate timepiece.
You do.
So that's something which is quite simple that anybody could do, really, even with a small telescope.
It is, yeah, it is. And it's nice to look back at the pages of data and think, well, you know, I've contributed to the understanding of the planet in some small way.
What a fantastic planet this is, though, isn't it?
It is a wonderful image, that.
Now, if you do get a chance to look at Jupiter through a telescope, I'd heartily recommend it. It's a fantastic sight. Now, there are a couple of other solar system objects which you might like to have a look at this month. One of them is the planet Uranus. And Uranus is much more distant than Jupiter, and it's much fainter. It's right on the threshold of naked eye visibility. But, as chance would have it, Uranus is very close to Jupiter at the moment, so you can use Jupiter as a signpost to locating more distant Uranus. Now, if you have a pair of binoculars and you point it at Jupiter, the next faintish star you can see above Jupiter is Uranus. Now, the pair are almost vertically aligned, or at their closest on the 19th of September, so that makes Uranus particularly easy to find around the middle of the month. Now, if you have a telescope and you point it at Uranus, then you can't see much detail, to be honest, even if you use a high power. But what you will notice is that Uranus has got a tiny disk and it's distinctly green in colour, and that's a fantastic sight. Now, the other object I want to bring your attention to is a comet. This is a comet known as 103P Hartley, or Hartley 2 as it's known, and it should become a naked eye object in October if it follows predictions. Now, comets notoriously don't always follow predictions, and I saw it a couple of weeks ago, and to me it looked a bit fainter than it should have been. However, whatever happens, it should still remain visible in a pair of binoculars, so it's definitely worth keeping an eye on. Throughout September, Hartley 2 passes through the northern regions of Andromeda, the chained princess. Now, Andromeda, as a constellation, looks like a wedge of stars coming out of the upper left corner of the Great Square of Pegasus. Now, I would say the easiest time to find it would be towards the end of the month, when it ends its passage throughout September very close to the star known as Cheddar in the constellation of Cassiopeia. That's the star at the bottom of the right-hand V of the W pattern of Cassiopeia. At this time, if you look at Cheddar with a pair of binoculars, you should be able to see a misty patch quite close to it, and that would be Comet Hartley 2. So if you get clear skies, go outside and enjoy these fantastic solar system objects.
Well, Pete and Paul, thank you very much. And now, for our news nights, Chris Lintott is on the other side of the Atlantic, but I'm glad to say we have with us Dr. Chris North. Welcome, Chris. May I begin this time? The Messenger probe is now approaching the orbit of Mercury and sent back this remarkable picture of the Earth and the Moon.
Yes, Messenger is going to enter orbit around Mercury in March next year, but now and again casts its gaze outwards from the inner reach of the solar system and has caught this image of the Earth and the Moon. You can see the Earth as the large bright spot and the Moon as the slightly smaller one. It really gives us a scale of the Earth-Moon system. We've seen images of the Earth and the Moon from other spacecraft. Cassini and Voyager have sent back images in the past, but this is the first one from the inner solar system from such a distance.
Actually, that's not Messenger's main quest, apart from Mercury. It's looking for volcanoids,
Yes.
asteroidal bodies moving around the Sun in orbits closer in than that of Mercury. So far, nobody's found any. Do you think there are any?
Well, if they're there, then they're going to be pretty hard to detect, certainly from Earth, because they're so hard to see against the glare of the sun. But from something like Messenger, it may well be possible to detect them. So if they're there, then Messenger may well find them.
Well, let's go further out now. Well, the Cassini probe is still going around Saturn and sent back this remarkable picture of the crater Penelope on Saturn's third satellite, Tethys.
Yeah, I mean, Cassini never fails to impress with its images. It's absolutely stunning. As well as this brilliant image of Tethys, it's also taken an image of Telesto, which is co-orbits with Tethys in the same orbit around the planet Saturn. Telesto is this very smooth asteroid almost body. It's very peculiar looking. And then, of course, we have Enceladus, the very peculiar moon.
In my view, the weirdest thing we've found yet.
Yeah, these plumes of salty water spewing from the tiger stripes at its south pole. And there's a number of images from Cassini's last flyby as it flew through the plumes. And there's also this brilliant image of Enceladus rising beyond the crescent limb of Saturn. So Cassini was on the dark side looking at Enceladus, and you can see the plumes spewing from the south pole.
An amazing thing. And now for our final news note, a very unusual neutron star.
Yes, this is a neutron star in the superstar cluster Westerland 1, which is about 16,000 light years away. Now, this neutron star is peculiar because it seems to be far too massive than should be possible. We think that stars that are between 10 and 25 times the mass of our Sun will form a neutron star, and anything more than 25 times the mass of the Sun will form a black hole. But this star, it looks to have been about 40 times the mass of the Sun and has still formed a neutron star. To do that, it must have shed an awful lot of its matter in its final stages. And that throws into question a lot of our theories about how these stars end their lives and how they die.
Well, you've got a lot of thinking to do. Chris, thank you very much. So until next month, good night.